And then for now, I'd like to welcome our well, I must say the face of Swarm, if I may say so. Viktor, I'd like to give you the floor.
Thank you. So hello everyone, and welcome to the summer school day 3. I will talk about the Swarm in a kind of from the perspective of technology in the context of a bit broader term and a bit longer term vision, and talk a little bit about why I think that Swarm is not just another dApp or just another coin, so to say, on the Ethereum blockchain. Why I think that this is a major game changer, and now in the view of the fact that we launched on mainnet, and we have operating network with real BUS tokens and the incentives proper. I will kind of focus on giving you a feel, a bit of a sense of vision and a bit of feel how Swarm as a platform might look like in the future, and what's in store in terms of the product roadmap and the features upcoming. So in general, the overarching line of the talk will be to walk you through this conception that Swarm is not only a project that uses Ethereum, but in fact Swarm should be considered to extend the Ethereum blockchain into a fully fledged computational environment, which is realizing the much coveted concept of the word computer, and serves as the operating system of the decentralized internet, and therefore it's a genuine next step in the evolution of decentralized projects. And I would like to approach this from various angles. First of all, to clarify again the vision of Swarm and put it in the historical context of this word computer. Then talk a bit about how I see the Swarm as the major ingredient in allowing and facilitating the decentralized world. In particular, how I think of Swarm's infrastructure as being the so-called narrow waist. I will talk a bit about what that means. I also would like to introduce a kind of a tentative paradigm that I call open resource, which is in some sense a continuation of the open source movement, and liken the impact and potential of the project to the open source movement in some ways, and introduce you to the idea how open resource is a major step towards the fully agile application development. Then talk a little bit about the primitives and the incentives which make Swarm also stand out, and also related to these ideas to the roadmap and how I see the ecosystem build up as we develop more and more features and more applications on top of Swarm. In particular, I will argue that Swarm provides just the right primitives, just the right atomic ingredients, which are simple and as well as flexible enough to provide the base layer infrastructure to build decentralized applications and realize the decentralized World Wide Web experience. So this is the plan today. So let me start with our basic motto, which is to build a future-proof base layer infrastructure for a global self-sovereign digital society. As you see from this is an ambition that has quite a weight of social ambition in it, and of course, by no means do I want to show hubris in saying that Swarm in itself realizes all of this. However, it can be a major building block, in particular in providing the technological layer and base layer digital infrastructure for services that can help and realize and empower citizens of a self-sovereign digital society. In particular, the adjective future-proof here means that the platform should be resilient against all kinds of potential single points of failure, and future-proof means that the access to material is controlled by their sovereign owners, and no middleman or gatekeeper is needed in order to publicly share and access information. In particular, I would like to emphasize our values and what this future-proof infrastructure implies with 4 eyes, or five eyes on the future, so to say. From mnemonics, these features are all start in our eye. So the infrastructure aspect basically implies that we appear to be a platform that empowers the citizens of the self-sovereign society by enhancing their productivity, provide a provisioning environment for their digital applications, and provides kind of plugins into this global platform. It has to be inclusive. Inclusivity means that the participation in the network is permissionless, and it provides public access and potentially global reach. It provides integrity, which means all aspects of cryptographically protected integrity. So there's no more hacking of websites because of content-less storage, the content-less addressing what the owners of a particular site or piece of information mean their users to see. The users can prove and verify that exactly what they see. So there's no more possibility of replacing a website just by hacking into their server, because the integrity is protected by the content addresses, and also provenance and tracking the origin of data is also an important part of this offering, and heavy emphasis on privacy features, namely private browsing and untraceable communication. Incentivization is very important in this regard. It's a very important ingredient of the future-proof nature of this project, because in order to have economic sustainability of such a network, it's imperative to align. It's imperative to align. It's imperative to align the motivation between the participant of the network and the platform itself. 1 second, I will share the screen. I think I'm sharing my slides. One second. Can you see the screen?
Yes.
Okay. So I'm talking about 5 eyes on the future. I talked about infrastructure, inclusivity, integrity, and incentivization. And the last one is impartiality. I think it's super important that the base layer infrastructure platform should be impartial in the sense that it doesn't discriminate between various types of content and remains value neutral. So it really treats content as bytes only, and doesn't express any particular preference or does not provide any direct control over policing content, and in fact allows individuals to express their freedom of speech and freedom of view through the platform. This is very important, because any kind of partiality built in the system is likely to provide likely to prove a bottleneck and later stifles in innovation and creativity and freedom of ultimately economic development to restrictions of various sorts. So impartiality is one of our core values. So in terms of the state of the project, after a series of events, starting with the event introducing the publication of the first version of the Book of Swan, which describes the technology and the motivation behind the project. After this series of events, finally led to the mainnet launch of the Swarm network in June this year, and this marks a very important milestone in the life of the project. Namely, it marks the fruit of changing from an R&D project into a proper product-driven development in the past few years, and that led to the final release of the mainnet client and the Swarm network, starting with the released bus tokens after the token sale. This important milestone makes a whole lot of difference in the way we talk about Swarm, because finally we kind of laid down the foundations and the atomic ingredients of the Swarm network are finally working, and we can the good work of realizing all these fancy products that we've been dreaming of in the past years can finally start, and the ecosystem can start to build up. And this is the kind of direction that I would like to outline and talk to you about. Why I think this is important, and what's both the economic viability and the historical importance of this. So so Swarm is ultimately providing the remaining ingredients that you need to realize the world computer. If you think of the Ethereum blockchain as the CPU or the central processing unit of a global computer, then you can think of Swarm as basically the realization of the hard disk of this computer. It provides the storage, the data, the storage, persistence layer, as well as provides the communication component between the different network nodes. And what keeps this system alive and economically self-sustaining as a network is the incentives, which basically incentivizes the optimal allocation of the computational resources, which in particular are bandwidth, so basically relaying messages, you share bandwidth as a node participating in the network, and also you configure computation and most importantly was from storage and disk space. And to optimally allocate these features, you need economic incentives to align the motives of the participant and make sure that ultimately the individual clients, the participants' of behavior are such that on the level of the network, behavior emerges which expresses the features that you want the platform to attain. So the individual clients rational self-interest ultimately gives rise to the global good and to the network level behavior of Swarm as a cloud service itself. This is exactly the Ethereum vision that conceives of this global computational resource as a word computer, and in the same way as you would think that the desktop applications operating system on a desktop computer is so there's an underlying OS that supports all the applications that run on a desktop. In a similar way, you can conceive of this word computer as being as providing the operating system that runs all the applications in the World Wide Web, and serves as the operating system of the web in a way a secure backend for Web3, for the decentralized internet. And this is kind of the final stage, or not final, but the next stage in the evolution of the internet, because as you remember in the days of Web 1, the decentralization was kind of more pronounced that lately in the phase of Web 2. This is basically because as the underlying infrastructure to run web applications, namely the hosts of and servers that run today's web applications, as they needed to scale in terms of the computational and storage resources that they provide, they needed to scale. Only particular companies that had the scalable infrastructure could be used, and therefore content providers were at the mercy of these companies, and in the process of providing often free access to their services and providing scalable infrastructure for the web applications, they often the content providers often fell victim to the restrictions coming from the fact that these platforms and infrastructure providers often owned their content. And Web3 is aimed at basically changing this situation for the better, and give back to the sovereignty to the content producers, and provide a scalable infrastructure that is decentralized and not at the mercy of any one particular company, and therefore more resilient to either human error or technological fault or any kind of jurisdiction or political or economic pressure that a company might be exposed to. And this is again a very important feature to provide the resilience that a future-proof infrastructure needs. So once again, the swarm is basically the can be considered this entry point where all the applications that want to be built with the kind of decentralized application can use as their base, and the platform provides the appropriate APIs via these applications. Now, in a way, it's important now maybe to address this idea of narrow waist. So why I think that Swarm makes a big difference and has a lot of potential. So I would not be the first to liken such an infrastructure to TCP/IP protocol on the level of networking. So TCP/IP is a protocol that scaled extremely well and has been used for a good part of since the networking is relevant in computation. And the reason it might have indicated against all the more feature-rich competitors is exactly its simplicity, yet apparent completeness, and it's similar to what we aim at. It was also impartial as to what application uses it on above, so to say, and what technology implements it on the network hardware level below. And this double cone structure, the leanness of this interface is what is often referred to as narrow waist. And having a narrow waist provides a huge potential for explosive evolution of applications, exactly because it can be resilient and time and resist the passage of time and remain a standard, despite the fact that the technologies that it is based on changing, and the requirements and the multitude of applications that build on it also change. So in the same sense, I can think of Swarm as providing this API that on the one hand, below, so underneath, it's basically quite neutral to what clients implement the Swarm protocol and the network protocols that define Swarm, and the incentives also provide certainty or assurance that the strategies that certain clients follow, they pursue, they are in alignment with the goal of the network. This is basically because it's to put it simply, it's basically costly. It's costly and therefore disincentivized for the individual nodes to divert from the winning strategy that defines the right behavior. So on the one hand, as I say, it's resilient to the client implementations that implement the protocol, and above, it's also in a way neutral to what applications build on it, because it just defines basic infrastructure primitives like storing blobs of data, and messaging between nodes in a network, and these primitives are the ones incentivized, and they are neutral to content, neutral to all kinds of usage patterns. So in a way, I would argue that in this sense, Swarm has a huge potential to serve as basically an infrastructure for the next kind of Cambrian period of explosion in the realm of decentralized applications, because it has the right primitives. It has a relatively simple base layer API, and at the same time it's flexible enough to express quite a great deal of super important features. I will demonstrate it and exemplify this in a bit when I enlist list the potential projects that can build on Swarm, or that are kind of on the roadmap for us. So once more, the Swarm can be seen as a narrow waist protocol that enables quite an efficient and quite synergistic application development on top, and therefore serves as a very productive platform. What I would like to also mention is the fact that the Swarm also can be seen as facilitating the open resource paradigm. What does that mean? It means that let's start from comparing it to the open source. So what the movement of open source was, as a kind of interestingly, we can think of open source as one of the ultimate applications of networking. So it leads to this example of TCP/IP, because it leverages networking to aid and facilitate the social collaboration of developers, and open source basically allowed projects to tap into a global resource or a global community of developers, and by opening up the source code, it allowed the massive improvement in the security, stability, and features of various applications. And the open source movement is economically super important, because it also transfers some of the development costs to users and interested inherently or organically interested contributors who wanted to contribute to the project. It facilitated this transfer of cost, and in a way, the open source partially eliminates the kind of costly recruitment and human resources cycle of quite a lot of that is quite burdensome on projects that work on closed source applications. And what's important here is that in a similar way, we can talk about the open resource, that an infrastructure that can run kind of a DApp in an infinitely scalable fashion. So irrespective of its data resource requirements or computational requirements at the end of the day, if you have a public and global infrastructure to pool these resources and provide the execution environment for scalable dApps, then basically similar to the open source, it leverages a global computational resource pool, and it has the potential to improve the testability, auto scale the deployment of applications, and ultimately eliminate part of the switching cost between applications, which also which all contribute to bringing down the price and the barrier of entry to innovative applications. And ultimately, it also has a transfer of cost effect, similar to the open source. It also transfers the cost from dApp creators to the users, because resources are paid for in Swarm. The burden of paying for resources is shifted to the users and is realized on demand as and when it happens. And this cost of transfer, so basically, to put it in another way, it can save innovative startups from having to set up funding for deployment needs, to set up a whole infrastructure team to manage their computational resources and scale them, and do it with a prognosis that is prone to prediction errors, and therefore there's a huge cost associated with that. So basically, the upfront investment is a lot of upfront investment is saved, and therefore the economic cycle of innovation becomes much more agile, and this also has a lot of potential for rapid growth in this field. So I would even say that open resources kind of eliminate so the fact that you have public infrastructure to deploy an app, it kind of eliminates the last bottleneck in agile and user adaptive evolution or development of applications, because so far with open source you can change the code, you can test the code, you can fork on GitHub and make your own version. But so far there has been a bottleneck in deploying applications that scale, because in the server client architecture, the server operator needs to pay for all the resources, which ultimately they can get from the users, but only with indirect means. In a platform like Swarm that provides an execution environment for that hosts the dApps, and it provides the deployment environment is basically the same as the hosting environment, and the cost of using it is directly burdened on demand on the user, and therefore this indirect monetization is no longer needed, and this short circuiting of this economic development cycle, there's a lot of efforts and resources that can be saved. So if open source can be characterized as fork your code on GitHub, Swarm can be, or open resource can be characterized as fork your apps on Swarm, and basically run the changed forked apps and potentially have a very agile deployment cycle as well, not just development cycle. In this sense, maybe I could illustrate it with the saying that Swarm makes the cloud its version control, or if you think about it as it helps you with brands, then basically it marries AWS with GitHub in some abstract sense. Once again, I also go a little bit into explaining the pillars of resilience in Swarm, because apart from the economic potential, it's also important what technologies contribute to the future proofness of particular storage in Swarm. I will not go into too much detail here. I just want to kind of enlist a few features. Some of them already exist, and some of them are in active development, and some of them are only in research stage. These ingredients that will contribute to resilience of storage and basically robustness of the behavior of the content access. So there's various pillars. First of all, there's local replication in Swarm. So neighborhoods that hold particular chunks of content locally replicate these chunks, and they are incentivized to do so. And by local replication, we can provide basic resilience against node churn. So if nodes go offline, then still in the same neighborhood, the the same content is found. We also have provide kind of a different kind of replication. It is not by instance replicating the chunk instances in the neighborhood, but in a way a client-side error coding. It's called erasure coding, and by erasure coding you can basically sacrifice some storage overhead for resilience of reconstructing the content, and erasure coding basically allows us to guard against intermittent arbitrary network failures, and because out of say 128 chunks, every 100 each 100 any choice of 100 chunks is sufficient to reconstruct the content. This is how the erasure coding works, and therefore this can ultimately provide assurance that it's not really important how the worst performing X% of the chunk retrievals can be made irrelevant, and therefore what erasure coding provides is ultimately an upper bound on the latency of chunk retrievals, and therefore it's a very strong resilience feature. It's coming soon to Swarm. Global pinning is another important feature. It's basically poor man's resilience. It's a feature that ultimately turns the somewhat different disk storage paradigm underlying Swarm into something that closely resembles the architecture of some of Swarm's contenders, in particular IPFS and BitTorrent, which are based on using the distributed hash tables, like basically Swarm-like retrieval protocol to figure out the location and the nodes where certain content is found. Global pinning is also a feature that makes Swarm fall back to such a solution. Basically, what it means is that you as a steward of some data. So if you're running a DApp, then you basically do content stewardship for that DApp, and if you allow your node to be a fallback recovery node, then through global pinning, this feature, if the standard network location is missing your content because it's deleted or because it has never been properly monetized and therefore deleted because of its insufficient value, then the protocol allows your node to be queried for this content, and therefore you're going to be automatically reconstructing this content and make it available for the network once again. So this is kind of a fallback solution for persistence. However, the most important feature of Swarm, of course, is the genuine incentives for network proper network storage. So storing the chunks that belong to a certain neighborhood, and this is done by the postage stamp pattern, which I believe that this has been discussed in the talk. But most importantly, the feature is it can be likened to a prepaid balance to charge rent for your storage and for the chunks. So basically, uploaders attach a prepaid proof of prepaid so proof of advance payment for their content, and this balance is used to continually deduct rent and therefore make the chunks render the chunks prioritizable. So basically, they can be ranked based on the value that they have attached, and this prioritization is exactly what nodes need to decide what content they should get rid of in the case of capacity shortage, and the price of this rent can be modified and changed, and with this price change, basically one can correct the network's imbalance in terms of supply and demand. So basically, if there's too many nodes offering a surplus storage and there's not enough content to store, then either because of then the price decreases, and as a consequence, maybe the unexpected lower revenue incentivizes some nodes to get out of the network, and the network shrinks, or it encourages users to upload more content because it's cheap to do so, and therefore exploit the surplus content, and vice versa. If the content, if storage provision becomes scarce, and there's too much content to store, then the price of storage can go up, and therefore it discourages new users to replace the release storage of expired content, or it incentivizes new nodes to come in and participate in the network as a result of higher revenue. However, this works only indirectly at the current implementation of the incentives, because it only works through indirectly through burning the impayments in the postage stamp contract, which is incentivizes through the deflationary pressure that this burning puts on the price of tokens. However, there's going to be a more direct incentivization for miners that store content by the introduction of the postage lottery. The postage lottery is a kind of informal term for the system that fairly reallocates the postage stamp revenue and rewards the storer nodes according to their contribution to the global storage. And this is coming soon. This is a very important milestone in the roadmap. So miners hang on tight that this is going to be proper redistribution of postage income, and not just indirectly through the deflationary force. And of course, there's further additional layers of potential assurances of resilience. Namely, there can be future providers which are stake nodes that promise to keep the postage batch alive. Basically, keep the content balance positive. Basically, promise against any price change. So basically, future providers are ultimately speculators on the future of BZZ and the future price of storage. So basically, for a premium, they would promise uploaders to keep their content alive, and therefore make the expiry dates more predictable for users. So this is a win-win situation, and the ultimate guarantee for persistence is what's so-called insurance, which is a negative incentive in the sense that it is aimed at handling the tragedy of commons problem, which is inherent in positive incentives. So if nodes that store content only get positive rewards for proving their storage, but no one gets hurt or no one gets punished if one particular chunk disappears, insurance basically rectifies this problem by allowing a construct where nodes stake and therefore become punishable if particular content that they promise to store will not be found and cannot be retrieved. And this provides very strong guarantees for this. And this is also coming soon, but it's actually it's potentially it can be built already now in certain forms, but decentralized way of doing it is coming soon. I would imagine within a year this will become possible. So these are the pillars for the resilience and persistence, and I would argue that this offering makes the future-proof nature of the project very strong and realistic goal, and therefore also contributes to the potential of Swarm being the base layer platform for the decentralized web. Now I think that the time is ripe to argue that it's not only the economic offering in terms of the shift of deployment cost to the users, and not only the narrow waist that contributes to Swarm's potential. It's also the right primitives, because as we discussed with the TCP/IP example of the narrow waist, it was very important that the primitives are both simple and flexible and expressive. Swarm is explicitly aiming in the future to provide a Swarm DSL, which would ultimately serve as a secure backend language, and I have the strong conviction that it has the potential to realize the proper secure backend for the web that currently is not existing, and the reason for that is that the traditional delineation of backend running servers and front end running in the renderer in the apps is made it possible to have some security on the backend side. However, this was non-transparent since it was running on the host and on the application operator's computer. Therefore, was uncheckable. You can do nasty, unexpected things, and the move towards client-side applications is compounding these two layers of backend and frontend, and it does not serve the desired security for web backends. And I think Swarm language is ultimately providing this delineation again, without compromising the client side nature of code execution. So this is the idea of basically introducing, like, this is just the tentative names, but introducing the Buzz language, which is scripting environment for Web3 backend, and allowing Swarm to host the application code in a kind of modular fashion. So basically, it's providing its own libraries and import context. So in other words, the application would basically run in the Swarm execution environment, and would source their code from via kind of sophisticated import paths through libraries, pretty much the same way as you would source the library components when you compile an application in a language like Node.js or Python, etc. Or sorry, in Python you don't compile, but it's in the same way. It's also executed when you do scripting. So the import can be done in kind of a lazy on-demand fashion. The main point here is that the execution environment is the local Swarm clients, and the resource and the code and the resources are from a secure curated environment of these libraries that are hosted on Swarm. This for the want of a better name, we call them IP areas. Finally, I would like to mention a few projects that would either contribute to Swarm providing like base layer services that other projects would build on, or themselves prove that the primitives are right, and we can use these to cater for high level needs that are particularly benefiting from a decentralized infrastructure. So I would like to mention four briefly. The first one is the good old swap-science window framework. So swap-science window framework is basically a framework to run to tender certain tasks and have a network of nodes that provides this service in a scalable way. What does this mean? So for example, you can tender indexing of a database as a task, and have a decentralized service network do the indexing of various sources for you. And swap-science window framework is basically a simple abstraction of how to formulate these tasks as games, as games of potentially challenging the players that don't comply with the promise of providing service. For example, if you have a flight aggregator service, then you would tender a swap-science window game that would collectively use the network of nodes to aggregate various sources of like travel agents publishing their flight offers, and the flight aggregator service would aggregate them. So basically, it's an indexing task ultimately in the backend, and this indexing task would be provably executed by a network of nodes in a trustless way. So since the correctness of their aggregate index can be proved to be correct or not, they can be challenged against their stake, and therefore the provisioners of this task can be a network of previously non-operating nodes. So nodes without having a reputation can trustlessly perform this task. And swap-science window framework is such a basically blockchain as a judge paradigm that allows for tasks to be published, tendered, and foul players not performing the task properly be challenged on blockchain. So this is a feature when done would make decentralized service networks available at a few finger tips to developers, and therefore would make all kinds of protocols, machine learning tasks, or various computational services which would normally require extreme hardware or very sophisticated computer cluster. This scalable computation becomes available, and its provision and deployment can be trustlessly yet reliably done through these service networks. This is the opposite offering of, or the other example is that kind of already proves that the swarm has the right primitives. Is the maybe the easiest example is to say that the signal protocol is doable on swarm, because it signal protocol basically exemplifies a de facto standard in how messaging is done, and how encrypted and secure messaging is done, and the way how a signal protocol can be redefined on swarm shows you perfectly how the two communication primitives, namely PSS, direct node-to-node messaging, and feeds, which is a kind of full type of communication primitive, and these can interact and provide basically these two primitives can build up any communication modality that exists. That is my claim. I was first envisioned in my talk in Prague in 2018, and since then there has been various efforts to build that, and I have to say that there's already a project called Waggle, which realizes the same basic tools and builds basically an email client, an email functionality on Swarm using exactly these two primitives. The other two examples I can just gloss over is one is video streaming, which would simply be based on the recognition that if all else is kind of irrelevant, one can be sure that decentralized peer-to-peer networks are super important in content delivery networks, especially in the context of real-time one-to-many video streaming. Because in these tasks, the server client infrastructure breaks down, and even reputable big CDNs, content distribution networks, resort to peer-to-peer solutions to deliver low latency video streaming. And I'm convinced that Swarm's forwarding cademia routing is providing a perfect opportunity to define such a video streaming plugin for content distribution, and can allow applications to provide one-to-many video streaming live with no specific hardware requirements on the originating node. And finally, the crown of war is database services. So basically, it swaps and swindle indexing and the very flexible ways of defining data structures on Swarm. We can have provable database services where all kinds of indexing and access patterns to data and data transformations are available to be provided through software and swindle games, and therefore provable data services are available and so on. Provable data services are not only important because they provide reliable and provable data, but this fact is also important because they are a public guarantee to against to challenge database service nodes. So if you want to combine the best of both worlds and use beefy database engines that do query caching and all kinds of very fast, low latency database access, their provision can also be done in a trustless way. So basically, they can be easily decentralized if there's a fallback provable data structure behind it. So with database services, it's not only data sets that can be efficiently accessed, but in fact can marry the best of both worlds, and you can also fall back to the traditional database servers that serve you the data, but you don't have to contract them or rely on a particular company, but you can provision these trustlessly in a decentralized fashion. So these were kind of examples of services which exemplify how swarms primitives can give rise to quite complex functionality that can contribute to smooth and complex application development. So basically, I would like to conclude. Today I argued that Swarm is basically the project of great potential, because it provides a realistic basis for a platform that can realize the open resource paradigm. Basically provides a scalable deployment and execution environment for dApps needing infinitely scalable storage requirements, untraceable communication component, or arbitrary scalable computation resources. It's also because of the simple and flexible primitives. There's a potential of Swarm Swarm acting as a narrow waist as a narrow waist protocol, serving the multitude of decentralized applications that emerge in the newly re-decentralized World Wide Web. And I also expressed particulars of the incentive system and various features of Swarm that contribute to its resilience and the promise that these primitives, the storage primitives and communication primitives, are indeed future-proof and due to the incentives, economically sustainable network can form. And with the price setting based on usage signals, with also a kind of self-regulating system which adapts the incentives to the particular configuration of or ratio of demand and supply in the case of storage and as well as other resources. And finally, I mentioned a few particular projects that can also serve to you as an indication of our roadmap and future vision. Some projects that exemplify the power of Swarm and kind of give you a good indication that Swarm defines the right primitives, so that these projects can be well defined and using just the simple tools that Swarm offers. Thank you for your attention. I hope I raised some interest in using the platform, and I hope that you can all contribute to the ecosystem, and I'm looking forward to seeing all the nice applications and platform emerging on Swarm. Thanks.
Thank you very much, Viktor, for that sparring talk on the state of Swarm and where we're going with it. We had a question from the audience about the current incentive system and its rewards. They said, yeah,
Yes,
currently there are, as a note, the rewards are still small, but as you explained, that might be resolved with the adoption of the network and the prioritization of the allocation being implemented, right? The deflation and price setting, which is still being implemented.
Well, it's mainly the redistribution that will make a difference, because currently the nodes feel that they are not rewarded directly, because they don't get redistributed part of the in-payments that come, part of the revenue that comes from the postage stamp purchases. But this will be rectified, and sooner than later this redistribution will be implemented by a storage lottery. The big challenge here is, of course, to prevent nodes that are that don't deserve to be paid for storage to participate in this lottery. So basically, there has to be a very reliable and very formally proven structure that that can reliably prove that the node participated in the storage the way the network prescribes, and those nodes that don't do that, this cannot spoof these proofs in any way. This challenge is quite hard, but I think we cracked it in at least 2 ways. So expect, watch this space, and this is gonna come soon. This reward mechanism of buffer, and of course other ways of staking storage with direct insurance and negative incentives are also coming, which will also provide potentially reliable revenue stream for miners. So, and of course, later in the day, participating in various swaps and seamless service networks and provide indexing services, etc., or anonymized mailboxes, etc., will also provide ways to generate income for node operators. Of course, this is all relying on the optimistic assumption that these services will prove useful for dApps, and there will be enough users to run the income for the operators. But of course, this is like with every project. I believe that this will be super useful services.
We've had a
question.
Yeah, another was we've had a talk by Elad Verbin yesterday, and he gave us advice to dApp developers that to build for the swarm of 2023 instead of the swarm at its current state, as just to build forward to what it will be. What is the next feature you're most excited about as yourself?
I can give 2 answers to this question. So one is, as a developer, wearing a developer hat, I'm most excited about the decentralized database services, because that will basically bring you the features that would make Swarm able to believably replace Web 2 applications. Because currently, of course, the client side execution pattern in our application, so that most of the backend calculations are also client side executed. These of course help Swarm, because Swarm is a serverless system. So if things came on the client side, then basically dApps can operate. However, we all know that all kinds of big networks like the Facebook of Swarm, for example, would run a lot of tasks on their servers, which are simply impossible to carry out on the client side. And these are not only access to databases, but also calculations and computation and aggregate statistics and all kinds of things based on a large data set, which have to be executed. And without servers, the execution of these computations have to be organized in a decentralized fashion. And Software and Swindle and decentralized data services solve exactly that. So they would provide the framework to build the same kind of complex web applications that you have currently on Web 2 in server-based architecture to be run on a Web 3 setting, the decentralized setting. So I'm most excited about that. And the other answer is that as a user, I'm excited about I would say kind of funnily that I'm excited about not noticing Swarm. So ideally Swarm is kind of desires to be seen as the TCP IP of the Web3. So in the same way as my grandmother who uses the web, we never know or notice what TCP IP is. It's kind of it's almost like running water that you don't care about the piping of the house to have water. In the same way as I'm excited about reaching a stage where Swarm is ubiquitous yet unnoticeable. It's the basis of running all these complex applications, but down at the metal you don't notice anything. It's kind of well hidden and reliably functioning. So kind of as a user, I expect to forget Swarm because it's ubiquitous.
Thank you, Victor. Yeah, for these answers.